Principles Show daily podcast by Anhui.
Okay, so today we're going to be diving into the world of quantum computers
Ooh, fun.
and medicine.
Sounds complicated.
Yeah, well, it is a little bit complicated, but it's also super fascinating, especially what's going on in China right now.
Oh, really?
Yeah, China is really pushing to be a global leader in using quantum computing for healthcare.
That's interesting. I hadn't heard that.
Yeah, there's a really interesting article from the BRICS joint website that talks all about how they just launched their very first quantum computing research institute that's dedicated to medicine.
Wow, a whole institute dedicated to that. That's a pretty big deal.
Yeah, it is. It really shows how serious they are about this.
For sure.
But before
Yeah.
we get too deep into all that,
Yeah.
maybe we should do like a super quick recap of what quantum computing actually is.
Right. Yeah, not everyone's up on all the science-y stuff.
Exactly. So basically we're talking about computers that can do things that regular computers just can't.
Like what kind of things?
Well, they use these principles from quantum mechanics, like superposition
Yeah.
and entanglement.
I've heard of those, but honestly, I don't really get them.
Yeah, they're pretty mind-bending.
Right.
So like with superposition, imagine a single quantum bit, which is called a qubit.
Okay.
It can be in multiple states at once, like a 0 and a 1 at the same time,
Whoa.
instead of just one or the other, like the bits in our normal computers.
So it's like it could be both things at the same time?
Yeah, exactly. And then there's entanglement where two qubits are linked together.
Okay.
And anything that happens to one qubit instantly affects the other one, even if they're miles apart.
Really? Even if they're far away?
Yep. That's the crazy part.
Wow, that's so weird.
Yeah, it's pretty wild stuff. And that's what gives quantum computers so much power.
I see. I see.
So now you can kind of start to imagine how all of this could be used in medicine.
Yeah, I can see how that would be useful.
Right, like you could analyze these huge data sets of patient info or simulate complex biological processes or even design drugs way more precisely than we can now.
Wow, that's amazing.
Yeah, it's pretty groundbreaking stuff.
Yeah.
So going back to this new institute in China, it's called the Bengbu Origin Quantum Computing Medical Research Institute.
Yeah.
And it's actually a joint venture between Bengbu Medical University and Origin Quantum Computing Technology.
So they're combining forces.
Yeah, exactly.
That makes a lot of sense. You need both the research and the practical application.
Right, you need those academic minds working with people who can actually turn those ideas into real-world tools.
Yeah, exactly.
And the article even quotes Guo Guping, who's the deputy director of the Chinese Academy of Sciences Key Laboratory of Quantum Information.
Wow, what a title.
Right. And he basically says that one of their main goals is to connect China's quantum computing power with their huge amount of medical data.
Oh, that's smart.
Yeah. I mean, think about it. China has a massive population, which means they have a ton of medical data to work with.
Right, a huge sample size.
Exactly. And that's super valuable for this kind of research.
Oh, yeah, for sure.
And the article also mentions this specific quantum computer called the Origin Wukong.
Oh.
Now, this isn't just some theoretical machine. This thing has already completed almost 300,000 tasks for users in 137 countries.
Seriously, it's already being used that widely.
Yep. It just shows you how real this technology is and that it's being used all over the world right now.
That's wild. So it seems like we're already in this future we've been talking about.
It really does feel that way. And it
Okay.
makes you wonder what kind of impact this is going to have on healthcare worldwide.
Yeah, I mean, what are the possibilities and are there any potential downsides? That's what I want to know.
Yeah, that's a great question. And that's what we're going to dive into next.
Can't wait.
Yeah. So let's get into some of those possibilities and potential downsides.
Okay, sounds good.
So the article actually mentions a few promising applications that are already happening even in the US.
Oh, really?
Like what? Well, they talk about things like more accurate breast cancer detection
Oh, wow.
and also faster drug development.
Okay, yeah, those are both huge areas in medicine.
Right, exactly. So let's start with the breast cancer detection.
Okay.
So apparently quantum computers can analyze mammogram images with way more detail and accuracy than traditional methods.
So they can spot things that doctors might miss?
Yeah, basically. And that could lead to earlier and more accurate diagnoses.
Which is obviously super important with cancer.
Absolutely. The earlier you catch it, the better the chances of successful treatment.
Right, makes sense. So what about drug development? How does quantum computing help with that?
Well, developing new drugs is a really complex process.
Yeah, I can imagine.
It involves simulating all these interactions between different molecules,
Okay.
and that requires a ton of calculations, like way more than even the most powerful computers can handle right now.
So quantum computers can do those calculations?
Yeah, because it can do multiple calculations at the same time.
Oh, right, because of that superposition thing we were talking about.
Exactly. So basically, researchers can design and test new drugs way faster than before.
And that could lead to cures for diseases that we can't treat now.
Yeah, potentially. Or even better, we could discover ways to prevent those diseases altogether.
Whoa, that would be incredible.
Mm-hmm.
Think about all the suffering that could be avoided.
I know, it's pretty mind-blowing.
It is. It is. And what about personalized medicine? I feel like that's another area where this technology could have a huge impact.
Yeah, totally. Imagine a world where treatments are tailored to your specific genes and lifestyle and environment.
Like custom-made medicine just for you.
Exactly. That could mean more effective treatments, fewer side effects, maybe even preventing diseases before they even develop.
It sounds almost too good to be true.
I know, it's amazing to think about.
It is. But we have to remember this is all still very new.
Right,
There are definitely challenges and downsides we need to consider too.
for sure. So what are some of the hurdles researchers are facing in bringing this technology to everyone?
One of the biggest ones is just the cost and complexity of building and maintaining these quantum computers.
Yeah, they're not exactly something you can just buy at Best Buy.
Right? They require all this specialized equipment and expertise.
Which makes it hard for everyone to access them.
Exactly. And it's not just about the hardware either.
Right.
We also need to develop the software and the algorithms that can actually use those computers for specific medical applications.
So it's like having a super powerful car but not knowing how to drive it.
Yeah, kind of. And that means we need a whole new generation of scientists and engineers who understand both quantum computing and medicine.
So it's a workforce issue too.
Exactly. It's not just about the technology itself. It's about building the whole infrastructure and the people to support it.
That's a massive undertaking.
It is. And then there's the question of access, even if we can overcome all those other challenges.
Right. How do we make sure everyone benefits from this technology, not just a select few?
Exactly. We need to make sure it doesn't just make the existing inequalities in healthcare even worse.
That's a really important point. We can't just focus on the cool science. We also have to think about the ethical and social implications.
Absolutely. These are complex issues, but they're conversations we need to start having now.
Yeah, before it's too late. I mean, it's easy to get caught up in the excitement of all this.
Oh yeah, for sure.
But we have to make sure this technology is used responsibly and ethically.
I completely agree. And that brings us to a really fundamental question. What kind of future do we want to create with this technology?
Yeah, what are the potential benefits and what are the risks we need to be aware of?
It's about making conscious choices and not just letting the technology dictate the future for us.
Exactly. We need to be proactive, not reactive. We have to think about these things now, not after the fact when it might be too late.
Right. The choices we make today will have huge consequences down the road.
For sure. And those choices will shape the future of healthcare for everyone.
Absolutely. But hey, before we get too serious again,
Yeah.
I wanted to circle back to that Origin Wukong computer you mentioned.
Oh, yeah, the one that's being used in over 137 countries.
Right. What kind of quantum computer is that?
Well, it's a superconducting quantum computer,
Okay.
which is one of the leading technologies right now.
So it's like the top of the line stuff.
Pretty much. And the fact that it's being used in so many different countries really shows how global this research and development is.
It's not just one country or one company racing to the finish line.
Exactly. It's a worldwide effort, which is actually pretty inspiring.
It is. It really is. It gives me hope that this technology could actually benefit all of humanity.
Yeah, me too. It's a global collaboration with the potential to revolutionize healthcare for everyone.
That's a great way to put it.
Yeah, it really does feel like this is just the beginning. I mean, this article focuses mainly on drug development and diagnosis. But what about all the other areas of medicine that quantum computing could totally transform?
Oh, man. The possibilities are pretty much endless.
Right. Like, imagine the impact on medical training.
Right.
Could you use quantum simulations to create, like, these super realistic virtual patients? And then doctors could practice on them and hone their skills in this, like, risk-free environment.
Yeah, that would be a game changer for med students especially.
Totally. And what about clinical trials? Do you think quantum computing could make those more efficient and accurate?
Oh, absolutely. Quantum computers could analyze tons of data to find the best candidates for trials. And that would speed up the development of new treatments for sure.
Yeah, that makes sense.
And think about this. We could use quantum simulations to actually predict how effective a new drug will be.
Whoa, really?
Yeah, before it even gets to human trials.
That would be incredible, especially for diseases that don't have any effective treatments right now.
Right. It's like we could skip ahead to the good stuff.
I know, it's so exciting to think about all the potential applications.
It really is. And as the technology keeps getting better, who knows what other breakthroughs we'll see.
Yeah, it's definitely a fascinating time to be following this field.
For sure. For sure.
So to wrap up our deep dive today,
Okay.
we've seen how China's investment in this quantum computing research institute is like a huge sign that healthcare innovation is going global. We've talked about how this tech has the potential to totally revolutionize diagnosis and drug development,
Right.
but also things like medical training and clinical trials.
Yeah, it's way bigger than just those things.
The possibilities are pretty much endless at this point.
They really are. And I think the key takeaway for our listeners is that this isn't just sci-fi fantasy anymore.
Right.
Quantum computing is already having a real impact on medicine,
Yeah, it's happening right now.
and it's moving super fast. So it's important to stay informed and keep up with what's going on.
Absolutely. We encourage you to keep an eye on this space because things are changing constantly.
Definitely.
And as you're thinking about all this potential, we want to leave you with one final thought.
Okay, hit me.
If you had access to a quantum computer, what medical mystery would you want to solve?
Whoa, that's a good question. I have to think about that one. Yeah, it's a big one.
Thanks for getting my brain working.
No problem. It's what we do here on the Deep Dive.
All right, everybody. Until next time, keep on diving.
And we'll catch you next time for another fascinating exploration.